Okay, this is video number 2 for two variable inequalities. Now we're going to be talking about systems. The process is the same as what we did in the last video, except now we're going to be putting multiple inequalities on the exact same graph. The key is you're trying to figure out where the shadings overlap or where they collide. So I'm going to go through the process, kind of the same thing we just did on the last video. So if I take a look at the very first one, I'm going to do some color coding here. I think it might help us out. So the one that I'm boxing in orange, we can see that the y is by itself. This is good. It's got an x, so I've got a slope and I've got a y-intercept. All right, so let's start at 0, -5. So on my y-axis, so 1, 2, 3, 4, 5. And then it's got a positive slope of 2. Now, if you don't see a denominator, remember you can always put a 1 underneath the 2. So this is going to be up 2, right 1. I'm just going to go ahead and put my points kind of across the graph. So up 2, right 1. So just doing the same process that I did in the last video. Just want to go across the graph. Okay, take a look at the inequality itself. Notice it has an equal to part, so this is going to be solid. So let's create our solid boundary here. Once my boundary is on the graph, now I need to shade this. So you can test a point like we did in the previous video, or you can read the inequality. Just be careful. Notice that the y is on the left-hand side by itself. Okay, so y, we're either going to go up or down, is greater. All right, so choose any point on this boundary. So there's my big orange dot. That's where my pencil's hovering. Y is greater. Greater is going to be above, which means my shading is all going to be up here. And I'm not totally sure where the overlap is going to be, so I shade across the whole graph. So I am trying to figure out where the shading or where the solutions for each inequality overlap each other. Okay, let's go to the second one. I'm going to use blue for this guy. So I'm going to do x is less than 6. Okay, so this is another one where I'm losing a variable. So it's either going to be a vertical line or it's going to be a horizontal line. So since this is x equals, I'm going to go to the x-axis, and I'm going to go out to number 6. So 1, 2, 3, 4, 5, 6. There's my blue mark. I am going to go through that location. Now, I'm going to pay attention this time because I didn't necessarily last time when we did this video. If you take a look at the inequality symbol, there's no equal to, which means this boundary is going to be dashed. Okay, once I have my boundary on here, and remember, if I had made a mistake with the whole dashed or solid, I could always just grab my eraser. Okay, now I want to do x is less than. All right, so any point on the boundary, so my big blue dot, x, okay, runs right and left. Less than, that's going to be left. So I'm going to go left of this line. Now, what I'm looking for with the system of inequalities is I'm trying to figure out where the shading overlaps. So what I can do is actually go through, so I'll use my blue pencil and I'll just make it a little bit darker. And you can actually shade where the orange and the blue overlap each other. So here we go. I gotta be careful over here because I don't want to go past those boundaries. So I'm going to where the overlap is happening. Just make sure you're not, so if you're to the left of a boundary, stay on the left of the boundary. If you're on the right of the boundary, stay on the right of the boundary. Just make sure that you don't go on both sides of the boundary. So notice I'm clearly above, kind of above left to the orange boundary, and I am left of the blue boundary. Okay. We've got one more to take a look at here. Now this one I wanted to make it just a tiny bit more complicated because I know you're going to have some practice problems like this as well. And it really is the same idea of what we did on the previous video. You're going to have to get the y isolated. So I'm going to go ahead and subtract my 5x to get the y by itself. Subtracting does not change the inequality symbol. I want my x to come first because that's going to help me with slope. And then I'm going to divide everybody by -2. Okay, dividing doesn't do anything, but dividing by a negative number flips your inequality symbol. So make sure that changes. I know a negative divided by negative is a positive, and then a positive divided by negative is a negative. Okay, now I'm ready to graph this thing. So I'll go on my graph and let's go down to 0, -3, plot that point, and then my slope of 5 over 2. So up 5, right 2. And then I'm going to go ahead and go across my graph. So 1, 2, 3, 4, 5, 2. And I think I might be able to fit one more down here. So 2. Okay. Take a look at the inequality symbol. Notice that it has an equal to part. So this boundary is going to be solid. After you've got the boundary on there, you can either test a point or read the inequality. So I'm going to go back to the highlighted inequality, the one that I manipulated. Now, hopefully I flipped my inequality like I was supposed to. So make sure that you know the rules here for flipping your inequality symbol or keeping it the same. Okay, so now we've got y. All right, y is by itself. So any point on the boundary, so I'm going to do that big black dot. Y is less than. Okay, less than is going to be below. So this is the shading for this guy. Again, go across the graph because we're not totally sure where this overlap is going to happen. Okay, next one. This one's really good. This one's already set up. So let's go ahead and put a 1. Whoa, that's too big. Let's go ahead and put a 1 in front of the x so we can see the slope. And remember, you can always put a 1 underneath it. All right, so this one's going to start at 6, a positive 6. 1, 2, 3, 4, 5, 6. And it's got a positive 1 slope. So up 1, right 1, up 1, right 1. Oh, I think I'm probably going to extend this guy a little bit. So I'm not careful. It's not going to look like it's overlapping at all. One thing to keep in mind is that the only graphs or the only straight lines that don't overlap each other are parallel lines. So if it looks like they're kind of tilted and pointing towards each other, they're going to hit each other. All right, looking back at the inequality, it looks like it's going to be a solid line. So let's go ahead and get our graph on here. Solid line. You'll notice my intersection is going to be up there. So I think I'm going to go ahead and extend the other one as well. It doesn't necessarily fit my graph all that great, but I think we can make it work. There we go. And then I'm going to finish shading my black graph also. So remember, I was going to the right over here. All right, back to the blue graph. All right, go back to that. Read the inequality symbol. Okay, so y, all right, any point on the graph, y is less than is going to be down. So from here, I want to go less. And then one of the things that we talked about in class when you're going through and you're shading the overlap, you could actually just erase where it doesn't overlap. So I think that's what I'm going to do on this one. So I'm going to make sure this below the black line, but I need to be below the blue line also. So you notice I just got rid of, and here I'll highlight it, this section up here that was below the black. And then I've got this whole section down here where the blue is shaded, but the black is not. So let's go ahead and get rid of that because there's no overlap there either. We are looking to see where the shadings come together. So we want the solutions that satisfy both of the inequalities, not just one. Or you could also go through and just make the overlapped section darker. Okay, so now the only shading that's on here is the shading where the two overlap each other.